Hello everybody, we have a lot to do. The objective, API initialization. Let's get to it. Right, so let's actually go to entry point here. So last time we've actually just worked on getting this written, so the API initialization code, and actually now that I look at this, I think PageMap should be just a double, and this here should be a quad. Right. So with this now, so hold on a minute. Page map, just looking for page map. Yeah, so we're just loading a double word from there. Okay, fine. Cool. So we have quite a few things to do then. Here we made sure that this is valid to the end of the page, and this makes it so that we could just point to this struct here from where we load the trampoline page. Right, so first thing we need to do is to go to bootloader UEFI source main and see where we got that trampoline page. Right, so we have that trampoline page here. We do log the address where we reserved that, but what else do we do with it? We actually use it here to log a few things, and then I'm thinking we just use that address here. Yep. So we move our kernel handover code to that trampoline page, and then we move on. Cool. So here's the thing we need to do. We actually need to move this trampoline address to the kernel. So we need to pass it to the kernel somehow. I'm thinking just going through boot info as we have done until now. So probably I'm going to take about 4 bytes from this. We know that the trampoline page will be in the lower 1 meg of memory, so that would have fit in a U16 at most. So maybe we can just take 2 bytes here and add trampoline pointer page, sure, as a U16 line 1, and that should be this by default, just so that we know that we got a page or not, because this address is actually not page aligned, so we can know. Right, so before we move on, let's just set this in main. So boot info, just as we've done up there. So here we can set trampoline address. That should be okay. So we go back here, and then we go to boot info in here. And so we need to go down here. Let me just center this, put this in here, and then we just remove 2 bytes from there. Cool. Very nice. So now what we need to do is actually go to I think SMP. Yeah, sure. And somewhere down here, just going to log debug trampoline page, and just with that. So here we are going to actually need, so we need to define an extern, which would be boot info, but I'll just copy that. Yeah, sounds good. Right, so let me just put that there. So boot info is falcon.bootinfo.bootinfo. And by the way, I don't have any completion because I tried to update ZLS and it's broken. Their master is broken. So yeah. Cool. So now that we have this, we should go here and do bootinfo.trampoline page. I think is what we have done. Right. So I actually also updated Zig, so I'm not sure if it's going to build at all. Seems like it's not. So hold on a minute. Exploit U16 found U size. Okay, that's actually fairly easy to deal with. So we go here and we add and cast to that. Okay. Okay, so I guess this is why I should update Zig. So this is in generate arc. And I guess, where is that? Arcs alloc. So this has changed. Right, well, stand by while I fix this. Right, so now let's actually run this and see where we were. So QEMU. And actually, I'm just going to go here and just use 2 cores for now. So going forward, we are going to test with 2 cores. Right. So trampoline page is F000, which is very good. And here we have 1 page of data, so we can just basically copy this into that, and that should do the trick. Right, so we go to SMP here. So I'm not sure where we should do this, but I guess we are going to do it here. So this would be mem copy of, so destination would be, so I guess we need to create a sort of buffer from that. So as many item pointer of, or I guess we should create slices directly. Yeah, sure. Now, actually, I like that. So let's create this. So trampoline pointer is many item U8 pointer, and this would be in pointer from int coming from boot info.trampoline page. Yeah, I think that's right. And trampoline. So yeah, so let's just call it trampoline slice, and this would be just a slice of U8, and this would be trampoline pointer from 0 to, I guess we can just do trampoline.trampoline data.length. That should work. Or not. Maybe we should just, force that. So constants, rather arc. Okay. Import arc. So arc constants default page size. Sure. Hopefully that works. No. So constants in here and default page size. That looks good. Right, so here we copy to trampoline. And the source, of course, is trampoline.trampoline data. Okay, so here we do have a problem. So trampoline page, right? And this is trampoline data, and this should already be like of course ZLS doesn't work, so we're going to know. We're going to know very soon once we build this if the types mismatch. So of course. Right, so what we need is actually just constants. That's import constants. Let's say. Right. Of course, here we need to remove this. Okay. And how do we make sure that this was copied correctly? So we can actually just log.debug. Trampoline, and we do something like this, and then here we do trampoline page, and we do something like this, right? Here we want so trampoline data, and we're going to just take like 8 bytes of that, and here we are going to take trampoline page, and we do pretty much the same here, just 8 bytes of that, and we make sure that we see the same things. Right. So let's see. Yeah, this might not be the best way to do it. So no, actually this is still not the best way to do it. How do we go about this actually? We could actually just use the stud format bytes to hex, I think. Yeah. So this still needs lower, sure. And we could do the same here. So format bytes to hex, and we can go here and do lower, something like this. All right. If this works, we're going to just move on to the next. Ooh, no, it does not look like it's okay. What is going on here? Huh. This does not look good. Not at all. Hold on a minute. We need to we need to go here and so let's find so in kernel zig cache. I'm just going to go for trampoline, and we have quite a few of those. So yeah, I'm just going to rmrf kernel zig cache and just have it go on rebuild. Okay, so if I do this now, I should get this, and if I guess the this probably just add a less in there. So here we have FLCNOS, which looks like what we have here. Yeah, okay. So why does the actual trampoline page not contain those? Huh. So wait, hold on a minute. Yeah, memcopy should just do the copy with no problem. So trampoline page is the destination and this is the source. So what is going on? And both of those should, in theory, be the same size. Otherwise, this guy here would have crashed. So source must be a slice, a pointer, or to an array, or a mini item pointer. Okay. So at least, okay, so I guess we could have not done this and just do this, and this should still have worked. Since the trampoline data would provide the size. So hopefully this now works. Yeah, no. Why is that? Yeah, okay, so I'm just going to do something before we do this. I'm just going to go here. And oh, I see why. Okay, fine. So I guess, wait, hold on a minute. This works. This returns a U8 array. So wait, let me just dupe this, set this back, set this back to string, put these two to hex, and just remove this and see if I could actually have had this as hex if I didn't put the string version or the bytes to hex. Right, let's see here. Oh, it actually does work. Actually cool. Nice. So here we should be okay. So now I guess we could actually just remove this and go for something like trampoline page initialized. Right, cool. So here we have done this now. We are done with this. So now we need to go ahead and do this here, this other step. So for this, I think it should be pretty straightforward. So we just go to entry point here. Here we have a start. We should probably have an AP start, strat start. Of course, Qualcomm is still naked and no return. And we should probably just do while true here. Just to make sure that our thing here doesn't crash. Our code stays live. Yeah, so this one wants this. Or we can actually just do this. Right, so this one is public, but we'd still want to have its value from anywhere in the project. So I'm not sure if this is needed, but so I'm just going to do something like this. Yeah, I'm not sure if this is actually needed, but I'm just going to do it for now. Right, so now we have this done. We need to do this sequence here. So I guess let's do that. However, we need to actually have access to so do we have access to the actual to the local epic here? How did we do in entry point to send right, so we used this, we used per CPU, we got the epic, and then we done the thing. So here we could probably do the same. We already have CPU, we have per CPU in CPU. So CPU here. Do we have per CPU? I think we do. Right, and here we send the IPI, and here we should probably do the I guess this one is init. Very good. So epic, and we probably go to xepic here. Right, so IPI message, just need to know how this works. So init has no parameters, and then we just set destination to all excluding self. Yes. And options just default. Right. So init here is okay. So all excluding self, I think. And then what's the problem? Wait, no. Should be like so. Okay, so this one is the init, and I guess we should add two more. This one is CP, but I'm not sure what that is. So, so that's startup here, and we need to send it the trampoline address. So startup, and this would take trampoline is trampoline, or rather boot info.trampoline page. I'm just checking that this actually this is fairly dumb. This is a U16. Yeah. Right, so this I remove, and then I send this again. So here I think in the documentation we have some sort of timing to respect between the two CP interrupts. But we are going to just ignore that for now. So can I do this? Does it not like it? Seems like it's okay. So the thing now is that we are going to see if this crashes. It does not like it. So so we're just going to add interrupt debugging and see do we have any idea where or which core this is? No, I guess not. At least I don't see it. Right, let's actually try to find. So we are looking for a trampoline. Okay, no trampoline for us. Let's run this again. And this time, yeah, let's actually run this again and see. This time I'm just going to, yep, there we go. Let's try to find trampoline. Still no trampoline. So, do we have any thing to do here other than debugging this? I guess not. So let's actually run this, and then we probably go ahead and set up a debugger. Right. So target remote, and here we want a hardware breakpoint on 0x F000. I think is where our trampoline page is. And we continue. Okay. Right, so here we have, it says we have 2 threads. So thread 2 is at BF whatever that is. And I guess we should probably do fine. And thread 1 is at that location at the page. Oh, actually, never mind. This is just the handoff to our kernel, so we can just continue there. Okay, so continuing this actually breaks thread 2, but thread 1 should still be going. So, oh, I see. No, build 64 elf. Okay. So, so I guess we have a bit of an issue here. Okay, so let's run this again. Let's run this again and see. Right, so fine. I guess info breakpoints, that should still work. I'm just going to check something here. Am I still allocating the same page? Yep. So F000, that should be still should be good. And now I should just continue here. And I am at this gen vector ISR, whatever that is. So thread 1, and what is going on here? Why are we executing this? This should be comp time. So did we mess up something in Xapic here? So let's see. So startup here, we get the trampoline, we shift it left by 12, and then we end it with FF. Yeah. So our pages should be 0F basically. That is what we should be writing to our register. But I'm not sure, so let me just take a look at the documentation. Right, so here in the documentation, we can see that we have, so thankfully they have hard-coded the values that they are using. So I think that if we just add, so log.debug here, send in IPI with ICR low, in this, and this should be IPI, right? So hopefully with this, we should see the values that we send. Make sure that they are the same. Okay. Problem here is that we don't see it. We don't actually see it. So here, destination. So what do they write to destination here? Nothing. Huh. And what do we write to destination? Should just write zeros to it. Okay. Okay, fine. So for now, just going to remove these two. And I'm just going to do this. So this destination and then IPI. So hopefully this doesn't crash anymore. Huh. Still does crash. Why is that? So somewhere right after we write this, one of these crushes us. send IPI init all excluding self. That should still go through this. So why does it not? Maybe Epic is bad. So debug Epic any Epic yeah, I'm not sure why this is so bad. Huh. So what is going on here? Right, let's what should we actually be doing? Let's actually move this up here and just make sure that this is what crashes us. So if we don't see the other logs, that would be an indication. Yeah, okay, so this is what absolutely destroys us, and I think I know why that is. This thing here might still not be initialized at this point. Hopefully that's not the case, but so hold on a minute. We do the init. Oh yeah, it's not initialized. SMP is initialized here and core is done here. Okay, so that explains a few things, I guess. So let's move on then. So let's leave the trampoline page set up there. That should still be okay. And let's just move this to entry point. We just want to check that this actually does work. So I'm just going to, whoops, this comes over here. And this now needs boot info. So we need to pull, so go back here. Where is that? Boot info. Right, so this needs to be pulled somewhere here. And of course, now we need to pull, so boot info is falcon.bootinfo.bootinfo. So with this, we should actually see something happen. Okay, cool. So, well, would you look at that? So ICR destination 0 and the thing here is 4007, which is not good because we expect this to be C45000. So C45000 means that we actually messed things up. So for the init, let's start with the init. So xepic here. So vector should be 000. So not sure why vector is 7 in our case. So why is vector 7 here? Delivery mode. Okay, I think I see what the problem is. Yep, I see what the problem is. The delivery mode needs to be moved. By how much is the question now? So I guess this should be it. Delivery mode should be moved by 8. Yeah. But that still doesn't answer the actual question, but we'll see. So this moves by 8. And now we'll see. So what is the problem? U2. Okay. So this one is U32. And I guess this needs to be endcast, or yeah, as U32, and then yeah, should do something like this, and this should just work now, hopefully. Okay, so 4, 5, but now we still have 0, 3, so I think destination shorthand should also be moved by some amount. So okay, so we have quite a few issues here with our implementation, but that's okay. So this 2 and destination shorthand should be moved by 18. Okay. So with this now, we should actually see the 3 transform to a C. Yes, okay, looks pretty good. So now we just need to do pretty much the same, but for the vector, no, not the vector, hold on. So the other ones are, let me find that again. Where was that? There we go. So this one is C 4, 6, and then 0F is what we expect. C 4, 6, 0F. So, okay, for now, they do look all right. So let's try to get those going. Okay, so we did crash our system, so that's good news. We have our other core must have started and then crashed. So so no reboot, I think, and no shutdown. Okay. So what is going on here? We have sent our IPI, and this triggered this exception here that must have killed us. But so here we can see that the instruction pointer is at F00048. So if we go over here and whoops, instead of XSD we do LVM or just classic opsdump mintel and b I'm not sure if it's just b binary like this or something, and then hopefully some m I3, something like this, and then something like this. Okay, so I've messed things up. Of course, we need to tell it that we want this to be deassembled. And I guess this should be like file format not recognized. Maybe we can just do this. No, okay, fine. Do I have that somewhere in my yeah, that looks okay. So now we can probably just do yeah, sure, let's just do this and have this be ed44 and this would be trampoline.bin. Okay. Right, so this one is something like, yeah, okay, finally. Right, so this one we add the, a less to that, and then over here I just want to add and adjust VMA to 0x F000. Cool. So now we know that the problem occurred here. So jump the word pointer EBX plus 118. So that's where our instruction pointer is, and the program counter also. And we know that in EBX we have this F000. So here we are looking to jump to so EBX plus 118, which should bring us to this, so F118. F118, so it's somewhere over here. Right, so okay. And that caused an exception, which is, I guess D is for general purpose. Just gonna have to, so exceptions. Just give me a list. Okay, you know what? I'm going to do this. So there we go. So here we go jump, and this thing here should, in theory, tell us that. So what is our jump like? So this one here, so it's 6, 7. So 6, 7. So it's not one of these jumps here. Hold on a minute. What's this weird jump? Okay, so it's jump. Did I forget to tell it that it's a for jump? Is that the issue? Trampoline assembly. So here I specified that it's a for jump, and I did also here. So no, that should not be the problem. Right, so let's go back here. So for jumps. So I was expecting to see EA or some opcode. Yeah, because this is what we actually encoded this here. So jump, the offset in 16 bits, and the actual, or rather the segment 16 bits and the offset in 32 bits. So that should be what we have here in Jumper. Or rather, we went for the 216 bits version, which is this here. So this should have been EA should have been an EA opcode. So why is this not an EA opcode? So here I see that it's an FF opcode, which should be still valid. I guess it should be okay. Address is given in M16 16. That should be okay. All right, so let's see what the GPs are for. So if 64-bit mode, we don't really care. Is there like a table? Yep, there we go. So GP, and what was the code for our GP here? So hold on a minute. Error 18, so that's the selector, I guess. Selector is 18. Okay. So if the segment selector index is outside the scroll table limits, okay, so I guess we have a good entry point here to check for the issue. So what is the GDT here? GDT is still, okay, so we still haven't loaded GDT, and we try to use, wait, so GDT hasn't been loaded here? Or did I miss something? Yeah, this GDT does not look good. We should have the address of of this in there. So GDT instead of this FFFF we have here. Right. So what is going on here? So let's actually try to debug this now. Now that we know it works, just going to probably not do that. There we go. So I'm just going to remove this and enable debugging. Cool. So let's go back here. So target is remote at 1234. Of course, we check our breakpoints, and we just reload the symbols. And I guess we can continue for now. Right, so where are we now? We are actually at the correct location. So RIP is 0x64. Let's just step or next instruction here. Okay, so I guess that is kind of broken. Whoops. Okay, so this is actually fairly hard. So let me just try something here. Just going to replace the segmented address here for GTR with just the actual linear or physical address. I guess we need to add this now. Okay, so still same problem, I guess. No, this time it actually progressed a bit, I think. for A. Or maybe we just offset the same things again. Right. So here's how we are going to debug this, actually. I'm going to move to AX, the D word in, I guess, EBX plus GDTR. And this way we are going to actually see in AX the value that contains before we load it, just to make sure that the GDTR we're using is has a good value. Oh, right. So now we can see that EX is 5.9. And hopefully here, so again, let's try to find trampoline. Yeah, I'm not sure which one is the latest one, but yeah, let's go for one of those and see. 23, something like that. Right, so 5.2 is the jump that where we crash in. Yeah, so that looks good. And the EAX has 5.9 in it. What? So EBX plus 5.9. No, that is not good. That's not good at all. What we need to check is, here we can see that in GDT we actually do have the correct values. The only problem we have is that we never override the actual pointer here, which is pretty funny. So I guess we are missing this. And I guess they should now just be fixed. Okay, let's see. Did we go any further? It looks like we went slightly further than we were before. Look at this. GDT now is set correctly, and we have the actual size correctly set. Now, what is the new problem? And as you can see it now, we are in 32-bit mode. We are in a project mode. So yeah, I guess we should be somewhere in here. And I am thinking that this program counter, so F09B, if we just go and find those, so I think this one would be A1. So F01, wait, hold on, 9B. So 9B would be this. So this is loading the effective address of, so that should be here, page map. Yeah, and this gives us E, and E I think is a page access error, which should be expected since we still haven't changed our page map here. So I think overall we should be doing okay. The only thing I'm expecting here is to see in C2 the offending address, but I don't see it. So let's actually get to this. And in SMP init here, we memcopy that thing. But what we need to do is, or what we also need to do is create a, so hold on a minute. We do have a trampoline.sig here, sure. But const trampoline let's call it params, sure. And this is a backed, is it backed? Extern. Let's try, sure, yeah, let's just have it be that. And now we take a look at what we have here. So I'm just going to invert these two for a better alignment. So I guess we don't have any alignment constraint. They all should be align 1. But okay, fine. So here we have entry point. This one is a U64. It should be an align 1 U64. Does this go after the thing? Yeah, okay. Then we have page map. This is a U32 align 1. And then we have status. Yeah. And this should be a U8 16. Double word. Yeah, so that's a U16. Align 1 also. And define this one. These two we need to actually write. Yeah. Yeah, okay. Good. So now here, let's define, so const or rather var. No, it's a const trampoline params pointer. Yeah, it's a pointer to trampoline trampoline params, and we get the pointer from int from pointer. So thinking here, this would be our trampoline page. So that would be, let's actually get that. Const trampoline address is info.trampoline page. Okay, so this one here becomes trampoline address, and this one becomes trampoline address plus so constants dot default page size minus size of trampoline dot trampoline params. So with this, log.debug, and we read those first. So trampoline params any, and we do trampoline params. Of course, pointer dot sure. What did I break here? So expected pointer found U16. Yep. So this one is pointer from int. Okay. So, integer overflow. How come? Integer overflow. So this trampoline address plus 1 page. Oh, I think I see why. Right, so trampoline params address is, this one is U64. Yeah, okay. So this one be intcast trampoline address. Yeah, so I think we are still going to need to give this, and then we add to that constants dot default page size, and then we remove size of trampoline dot trampoline params from that, and then here we can just now use trampoline params address. Hopefully this doesn't overflow anymore. Right. Okay. So where were we? Right. So here we have entry point. So I should probably just done something like this trampoline params pointer dot page map. Sure. Okay. So do we see the same values? We actually do see the same values. So we have the correct trampoline params. We can get rid of those now. And now we can actually go ahead and set trampoline params pointer dot entry point is I guess here we need to get extern var ap start, which should be a const function that takes nothing, that has a call conv of naked, and no return, I think is how we should go about this. And yeah, I think that's pretty much all there is to it. Right, so entry point here is ap start. I guess we should do int from pointer here just to make sure that this is valid. Params pointer is, so we need the page map. Right, so here is where things get a bit complicated, because where is the page map defined? I think we should, in theory, I think we should have something here in boot info, of course. Boot info. Do I have like page map here? No. No, we don't. Actually, if we go to vmem, so here the way we get the page map is by doing the so here. No, should be here. Of course. Let's just find this directly. This one should be here. Right, so here we get page offset. Is we try to read the page offset from the config, and then we have root, which is this. So I guess root is the address of the page map. So if we call this, we should get the page map address. So for now, let's just put everything in here, and we are going to do. So hold on a minute. So that'd be Falcon memory. So that would be somewhere here. Vmem, or wait, no. So it would be in memory here, and then in kernel vmem, and then we call it from there. Okay, so this.kernel vmem, and I think this would be impl.root. So hopefully this gives me an error message that's readable. So expected type U32 found U64. That's actually pretty good. So I'm going to intcast this. Yeah, I'm going to intcast this. And actually, I might, just before we do, anything here, we just might reprint trampoline params after we write to them. So this would be trampoline params pointer dot entry point, and trampoline params pointer dot page map. All right. Okay, one more small error, undefined symbol AP start, of course. Yep, that's what I wanted. So this one here is this one here. So of course, okay, looks like it actually went ahead with that. So we want to check that. Oh wow. I'm not sure about this one here. Yeah, I am not sure about that one there. So maybe something like this. Yeah, no, nope. Nope, nope, nope. It's going to expected type U64 but found a pointer to function. Right. Okay, so what is the actual problem here? So trampoline endpoint is so AP start. AP start should be well, it should be within the range of our kernel, so it should be somewhere inside this virtual address here. So let's actually try to log debug AP start. Just going to do this and AP start here. Just want to make sure that we do have a good value there. Okay. Yeah, we'll see this is not good. That is not good. So maybe I should do just something like this. Yeah, but now it's going to complain that it it's going to complain that it's not going to work. So I guess, do we really need that there? Can't we just do something like maybe here const AP start is at import entry point, let's say .ap start. Is this one public? It is. So yeah, I don't know. Something like this, maybe. Right. Something like this, maybe. And now it's going to complain for, yeah, of course, I've got this here. Let's see. Okay. Okay, so we do now have a correct address, at least an address I expect to see. Great. So now what is the problem still? So I'm looking for the page map. Where is CR3? CR3 is still zeros. So how come CR3 is still zeros? So does that mean that when we set CR3, so hold on a minute, that should be around here. Yeah. So this here should be where we set CR3. So what's a register we haven't touched yet? So EDX, let's actually move EDX or move EAX to EDX, just so we can see which value we are setting to CR3. Right. So EDX is zeros. Huh. Okay, that's not great. Right, so we know that we should have the correct value in EDX because here in ECX we have C zeros and 80, and we should still see that here. Yeah, So EDX has the actual value we've loaded to CR3, which is a bunch of zeros. So this instruction here should have a problem. Right, so let's actually get this, let's analyze that. So I'm just going to RF the cache here, just rebuild it. So otherwise, just going to not find it. Right, so this one here is that, and this should be 8, 9. Good. Right, so we are at 9B. 9B being, wait, hold on. 9D, okay. So 9D is here. So this is the load effective address that's missing. And we have a problem with this, actually. So in EAX, we load the address pointed to, or the value pointed to by EBP. Okay, I think I see the problem. Yeah. Okay, fine. Small mistake. Happens. Okay, so let's see here. So we moved forward. Yeah, we did move forward. But we still have another page fault here, and the actual page is 1 to 8. So let me just check that we have the correct page map here. We do. The faulting page is 1 to 8, which is not an actual page. And I think it should be probably this instruction here. But we'll check. So we said A3. A3. Yep, looks like it. Or wait, hold on. Yeah, it looks like this is the issue. So I am going to replace this now, this segmented access, by just doing the actual real address computation here. And probably this one would also need that. Okay. So let's see. Okay, so we still have another problem, but this time we have jumped. It looks like we are in real mode. So we have jumped here. And then RX, okay, so I guess here we are just missing. Yeah, just need to load the actual value from that address. So this also needs to become EBX plus thing. So if this all works, we expect to see that our other core starts and our current core just continues on. And it looks like we are correct on this. So let's try to actually do something here. So how do we go about this? How do we go about this? Let me think for a bit. Okay. Can we actually go to CPU in here? I am probably going to regret this, but pub variable CPU ID As I said, I am probably going to regret this, but let's just see where this takes us. So atomic value align to, do we have like cache line? Sure. And of course, value takes a t, CPU ID. And this is, do we have like an init or something? Init to 0 something. Yeah, I'm just going to do this. Right. So, just thinking here. Actually, let's call it CPU count. Sure, let's call it CPU count. Right, so here we, before we do any of these, so just after we do this, I'm just going to do CPU count dot, so fetch add 1, and I guess we don't really need any strong locking here, so I'm just going to go for monotonic. Does this fail? No, it shouldn't fail. And this returns the older value, I think. Yeah, it does return the older value for this. So, okay, let's now go to entry point here, and apt start, and here we are going to go cpu.cpu-count.fetch add 1 monotonic, and what we are going to try to do here after this thing has finished, we are actually going to count down, which is something that we should have done before, but we didn't. But probably not this much. So just probably going to count down for 10 milliseconds. Let's actually count down for 20, and then we'll call it even. So now we are going to try to log.info and do CPU count. And here we can do cpu.cpu-count cpu.cpu-count load, I think. Yeah, we'll see what the error is. So value of type U32 ignored. Should be fine. And we should probably do this also here. So load expects 1 argument, just not know what that argument is. So load expects, yeah, okay, so the ordering. So I guess here for the ordering we need to acquire, yeah. So what we are expecting is to see CPU count at 2 if everything went correctly. And would you look at that? I'm just going to make sure that this before just returns 1, and that it is our second core that sets us up to 2. and 1 and 2. Very nice. So let's now try something. Okay. Let's go for 8, and we should expect that count to be 8, but it's not. How come it's not? So we have a problem here at 4F. So IP 4F. So 28 is correct. And AX is 1. Wait, hold on. Why is AX 1? That's kind of weird. So here, did we already load the page map? No, we still haven't loaded the page map here. So what is going on? So PC is 04. That is not a valid address at all, but the segment is 28. So the only point at which we set the segment to 28 is here. So this should be this far jump causing the issue, probably. But I'm looking at CR3 and I don't see the page map being loaded. So yeah, that's kind of weird. It's kind of weird. Looks like we are still in 32-bit mode for some reason. Oh, I think I see what the problem is. Okay. I think I see what the problem is. The problem is that we have now released all cores to use this single jumper thing, and they all will try to write to it at the same time. So some of them will see the correct offset, and some of them will see the offset that has been written by the other core. So what we need to do is split this jumper to, we know that the value of the jumpers should be the same across cores. We just need, so here, these two values here are fixed. And the two values here are also fixed, so we don't really care that they fight or override each other on these values, because they will have the same value at the end of the day. It's just that when one of the cores is already transitioning to long mode and the other one isn't, we have the issue. So what is the problem here? Undefined symbol jumper. Yeah. And of course, here. So hopefully with this, we should see all cores start up, and we have all cores fired, and we have 8 running CPUs. Well, 7 of them aren't doing much, but yeah, we are getting there. Yes, we did it. We have poured through and have initialized our cores. So we now can get our cores up and running. It was kind of painful, and as you might have notice I am a bit under the weather for the moment, but I knew that I need to do this, otherwise I'll just not do it for a while. The code, on the other hand, is a bit of a mess and it needs cleaning up, but otherwise, it's a great success. Tune in next time. I'll see ya. Fucking out.